Welcome to another Level 3 probability distributions video. This is our last video for binomial, the second part of step 5. Alright, well remember in the last video we looked at an example where we had to calculate the probability of winning for each ticket. So we had to calculate a missing P for success, the probability of success. Well, we're going to do a similar process in the next example, but we're now going to calculate a missing N value. So let's get into example 2. Lotto wishes to change the number of scratchies in each packet to make a new claim. With N tickets, you are guaranteed to win at least one prize 90% of the time. The probability of winning for each ticket remains at what we calculated in the last example, P for probability of success, which is 36.9%. So in this example, we don't know how many tickets in each packet. N is the one we're missing. We do know the probability of success, 36.9% or 0.369, and we can work out Q because P and Q add up to 1. So Q is 0.631. Alright, this 90% represents at winning at least one prize. So the probability of X being greater than or equal to 1 is 90%. So once again, let's go back to our distribution table. These represent how many prizes you win. So you could win X of 0 prizes, 1 prize, 5 prizes, or 10 prizes. This 90% represents at least winning at least one prize, which are all these probabilities here will add up to 90%. So what we're going to do is write down P of X greater than or equal to 1. The probability of winning at least one prize is 90%. We're going to subtract that away from 1 like we did in the last example. That leaves us with a probability of X equal to 0, winning 0 prizes of 0.10 or 10%. And that's going to be popped up in this box. So we know the probability of winning no prizes is 10%. And that's the number we need to carry on with this problem. All right, so once again, we write down the binomial distribution formula. If you're not confident with it, go back and carry on rewatching the videos and practicing until you are. We're going to replace the small x with 0 because that's what we have, the probability when x is 0. We're going to replace N. No, we don't actually know N. That's what we're trying to figure out, so we won't replace that. We do know what small p, the probability of success is. Small p is 0.369. Let's replace that. And Q we know is 0.631. All right, let's show you how we solve this equation. We do know that the probability of X equal to 0 is 10% or 0.10. So I'm going to replace that with 0.10. I know that NC0 is 1. That's because NC0 represents N factorial, whatever number N is, divided by 0 factorial times bracket N minus 0 factorial, which simplifies down to N factorial over N factorial. And that just means one number divided by itself, which is 1. Always keep in mind that 0 factorial is defined as 1. We also know that any number raised to the power of 0 is 1, so this will simplify down to 1. And here we've got 0.631 to the power of n minus 0, which is 0.631 to the power of n. Right, well this simplifies down to 0.10 equal to 0.631 to the power of n. Let's move up here for some extra room. Now we're going to use a trick we learned in Year 12 algebra. We're going to take the log of both sides. And a trick we learned in Year 12 algebra was if we have the log of a number raised to the power of n, the n comes out the front and multiplies by the log. So the n is going to come out and multiply by a log of 0.631. Then we can just divide everything by the log of 0.631, and that cancels here, leaving n by itself. And we can grab a calculator and work out the log of 0.10 divided by the log of 0.631. We're going to round it sensibly and say n is equal to 5. And our claim is now, with 5 tickets, you are guaranteed to win at least one prize 90% of the time. Thanks for watching.